So in this video, welcome to Electronics Techie. So in this video, we discuss about another Verilog code which is related to the logic gates only, but it should be in the data flow modeling. So yesterday means in previous video we discussed about gate level modeling, same code but using the gate level modeling, but here we can same code with data flow modeling. So how we can write in data flow modeling is nothing but so same as before. First you have to start with module and end with end module. So initially you write module here, and data underscore flow underscore modeling is nothing but your module name. So you can represent with any name, but your better understanding you have to represent what the code what is the code hardware like that. So here is the data flow modeling, that's why I represented with data flow modeling. Then after few days later also if I watch these code means, then I understand that it is related to data flow modeling by seeing these module names. So I have to define like that. So inside those braces what you have to represent with ports. So for any gates they are the inputs whereas the outputs. So AB are the inputs, same as in previous video we discussed that. So AB are the inputs and whatever the output it is NAND gate. So NAND underscore out is my output I represent. So input means simply you write input means it take as A and B are the inputs. So what is the output for this? Sorry, it is end. So end underscore output is the output of the AND gate. So I write AND gate. So I want to find out all the logic gates outputs. That's why I take for the same inputs of AB. For the same inputs of AB, I want to calculate the output of OR gate, NAND, NOR, like that. Every gate I want. That's why I represent OR, NAND, NOR, NOT, XOR, XNOR. If I write XNOR and like that, means they are the keywords. So you don't write like this. So you have to represent which is not are the keywords. So end with semicolon. So till now I think it is okay. You start with module and here it is a module name. Data flow modeling is our module name, and inside the braces we represent inputs and outputs. What are the inputs and what are the outputs, and end with semicolon. So till now it is okay. So in data flow modeling we use the assign keyword. So what is assign keyword? In data flow modeling we represent what you want to assign the function with to the output. It will be used by the assign keyword. So what you want to assign, so what are the inputs, what is the operation it will be done, so it will be updated to the output side. So we have to update those values by using assign keyword. So here AND gate, for AND gate we can in Verilog, so every primitive means every logic gate has something symbol like that. So for AND gate the symbol is like this. For OR operation we can represent with single line. So for NOT we can represent like this. So NAND it is invert of AND, so we can represent like this, or we can first AND operation like this. So we can represent anyway. So NOR is nothing but inverse of A or like that. So XOR is nothing but this symbol, and XNOR is nothing but inverse of or like that. So here I write clearly for XOR it is symbol like cap symbol. So XNOR is nothing but inversion of cap or cap after inversion. We can represent the logic gates like this. So in Verilog, so here you can see for end output. For AND gate output what you want to do, so A and B are the inputs. So have to end operation these two values and output the assign the output value to the end, means I represent these out as the end underscore out. So I have to represent these inputs end operation to the output underscore end. So I represent same as here, end underscore out equal to A and B. So OR operation I use this line. So for NOT there is a inversion symbol I have to write here, and NAND underscore is nothing but so whatever you get the AND gate output it is the inversion mix. So AND plus NOT is nothing but our NAND. So here I simply write, so I can done AND operation between A and B, and I add simply the NOT gate. So then I get NAND gate. So I write like this. So NOR. So for OR gate NOT means so OR plus NOT is nothing but our NOR gate. So A or B I simply add NOT gate, so we get NOR output. So I write here. So XOR is nothing but you can represent with cap symbol. So end with semicolon. So for every line we can represent Verilog this end of the line is represented by this semicolon. So don't forget while you end of the line. So assign XNOR underscore out is equal to, so inversion of XOR is nothing but XNOR. So like that we can perform the operation, and then we can assign into the RHS side by using this assign keyword. So after the code is completed we have to end these modules, so we can simply write end module. So it is like design code. If you have any doubts in design code, if you have any particular point like this, so you have to comment it. I will try to make separate video on your doubt. So next, look into the test bench code. So how it looking like that, as before, it will be start with module and end with end module. It will be common for every code. So first we have to write module. So here also you can write any module name. It may be related to code, means you have to better understand after few days also. So it is like module name. So you can represent, here I represent Dataflow modeling underscore TB like that. So whatever the inputs here we take, so you can represent those in range. So inputs are maybe range in test bench, inputs are maybe range or net data type, and output may be only net data type only. So here mostly we prefer inputs for range data type. So range a comma b for while. So you can represent whatever the outputs here. So you can represent all outputs here. So here we have to instantiate the, means connect the ports. So you have to connect these design code inputs. These inputs are connected, means now you have to give the values to the inputs. So a and b, so 0 or 1 like that. So for that you have to connect the ports. So how you have to connect the ports? So in design code, what is the module name? Here in the design code, whatever the module name we take, so you have to write here, and we can instance by any name. So mostly we use DUT. So it is nothing but design under test. So why I wrote Teju means, so I want to tell you about not only for DUT, for using any instance name it will be work. So I try to notice that point, that's why I make like this. So mostly in Verilog for your design under test, so mostly use DUT and DUT like that. So here I use Teju, but for your clarification, means whatever the name you can use your name also, so no problem. That's why I mentioned this. So don't confuse here. So now you have to connect these design code inputs and outputs to this test bench code inputs and outputs. That's why I connect by port by name. So port connection by name. So already in previous videos we discuss about port connections and those are. So if you don't watch, then go into that video, then you can understand how these connect by ports. There is a port connection is by name, so or by order. So by order means it may be there are the so many inputs or outputs, so it may be clumsy. By name means we can simply know, understand, and we can assign properly. That's why we mostly prefer name. So when we have more inputs and outputs, so here by using port connections, you have to connect these test bench and design code inputs and outputs. So now we have to give inputs and outputs, means we have to apply inputs, then you can get outputs. So for applying inputs, so what you have to do, we have to start with initial. So whatever the, why you have to write the initial block means, so whatever the statements in the initial block, it must be displayed serial manner. So whatever, so in mostly test bench we have to write that initial block. So whatever the statements inside the initial block, it must be executed serially like that. So if you have only single line, it doesn't represent any begin and end statement here, but there is a multiple lines. That's why you start with begin and end with end. So inside what you have to do is to first initially, so I write /5. So what is represent? So if it is a time scale, so first 5 seconds, it may be unknown values. So I don't know whatever the values is. So after 5 nanoseconds or after 5 seconds, what you have to do, make a value is equal to 0 and b value is equal to 0. So then again 5 seconds. So 5 means 5 plus 5, 10. After means at 10 nanoseconds, so a value will be 1, a value will be 0, b value will be 1. So again we give 5 delay. So 10 plus 5 is nothing but 15. At 15 nanoseconds, so your a will be 1 and b will be 0. So like that, for using slash, we can represent the delay of the time period between the change in the input. So every 5 seconds of nanoseconds of delay, we can change our inputs. Also after 5 nanoseconds of your changing, then you have to stop the stop our, means at something, means 5 plus 5 10, 10 plus 5 15, 15 plus 5 20, 20 25. So after 25 nanoseconds, your simulation will be stopped here. So no further simulation. So that's why what you have to use, so $finish we have to use. So by using $finish, we have to stop your simulation for particular time period. So for this begin, we have to stop. That's why use end here. For this begin, we can use end here. So next what you have to do, so if you want to display anything, so you can write again initial begin like display and end like that. So initial begin means, so why I wrote means, so I am doing code. It is a open source. First I have to say this. So it is like EDA playground. So if you don't know where you have to make the codes and where you have to run, so it is a open source. It simply you don't want any app also. You simply go to EDA playground and then log in with your mail and you have to password. If you don't have an account, you can create and log in with your Google account or any personal accounts or college accounts like that. So then simply you can use this EDA playground. If you want further explanation of this EDA playground account, you can comment it. I will try to make separate video how to how to operate the EDA playground account. So for why you write these 4 lines initial to end, these 4 lines why I write means, so for waveforms, so whatever the waveforms you want, so for these waveforms you write these 4 lines. So end module is end with end module. So output waveforms is like that. So first we have to see, so starting initially in this test bench, after 5 nanoseconds we give A and B values. For before 5 nanoseconds what is our values we don't know. So that's why here it's represented with unknown values. So after 5 seconds the input may be 0. So here I take the line. So see these values. So A value is equal to 0 and B value is equal to 0. So is nothing but, so 0 into 0 is nothing but 0. So again AND gate output inversion is nothing but NAND gate. So 0 is converted to 1. So A value is equal to 0 and B value is equal to 0. So first we have to find everything, AND, OR, NOT, NAND, NOR, XOR, XNOR. We can done theoretically, then we go to practically. So A and B values are 0. So 0 into 0 is nothing but 0. 0 plus 0 is equal to 0. Inversion of 0 is nothing but 1. So 0 into 0 inversion means we get 1. So our XNOR, NOR gate, okay, means 0 plus 0 inversion is nothing but our NOR, so we get 1. So again XOR means 0 is nothing but we get 0. So 0 means XOR symbol is like this. So 0 XNOR 0 is nothing but our 1. So now cross check these values. So AND. So AND gate value is 0. So for NAND gate the value is 1. Okay, it's correct. So NOR gate its value is 1. Okay, it's correct. So NOT gate its value is 1. Okay, correct. So our OR gate our output will be 0. Okay. XNOR we get 1. So XOR we get 0. So like that we can cross check your theoretical calculations and as well as simulation values. Then by that you can get proper understanding about this. So until then, thanks for watching. If you have any doubts you can comment. If you want any further codes and explanation you have to comment it. I make the particular videos and clarify your doubts. Until then, bye.